Metaphysical frameworks, both cognitivism and functionalism, although remaining the mainstream and to some extent the dominant metaphysical positions in cognitive science, have been under serious challenge over the last few decades. This unit of the course presents a fairly wide variety of theories from philosophical, psychological, and neurophysiological perspectives, which are contributing to this undermining of cognitivism and functionalism. Functionalism, qualia, but only as epiphenomena to functions. At a minimum, functionalism does accept the existence of inner mental processes, even conscious ones. The more liberal versions of functionalism even accept the qualia which, as folk psychology insists, are often associated with inner mental processes. However, functionalism's concession to qualia turns out to be only a marginal advance on behaviorism's absolute denial of their existence. This is because functionalism, as its name implies, focuses almost exclusively on behavioral functions as the important factors in biological evolution. Natural selection favors those neural mechanisms which most successfully mediate the behaviors required for survival and reproduction. In functionalism, therefore, the evolution of qualia occurs only parasitically via their linkage to behavioral functions, which are the really important phenomena from a Darwinian point of view. Again, functionalism fails to advance much beyond behaviorism, in failing to take any particular interest in the biological details of brain processes. Functionalists do take into account the detailed circuitry of the brain that mediates between input and output as part of the full description of a function, but they're interested in it only as circuitry. Essentially, functionalism simply added a mental black box to the middle of behaviorism's even more basic stimulus-response model. In other words, the tissue out of which brain circuits are made and the means by which the circuits operate are regarded within functionalism as irrelevant. In principle, the functionalist holds one could mimic the circuitry with any materials to hand, and the result, in terms of either conscious or unconscious processing, would be the same. Same functions, same processes. If the relevant brain process attains consciousness, so would the same function no matter what material was used to carry it out. Given this very tight linkage between processes and functions, with qualia as epiphenomena of both, functionalists, therefore, would not expect to find any qualia which are either irrelevant to, or worse still, might interfere with, one or more behavioral functions. As Gray explains, a functionalist account of the ability to discriminate the difference between red and green depends entirely on evidence from outward behavior. Quote, I shall describe function as taking the form input mechanism output. If a full functional account is given, then according to functionalism, there is no further answer to the question, what is the difference between the subjective experiences, the qualia, of red and green? According to functionalism, qualia just are the functions, input mechanism output, by which they are supported. End quote. Questioning functionalism. Word color synesthesia. Gray summarizes this key functionalist contention as follows. Firstly, for any discriminable difference between qualia, there must be an equivalent discriminable difference in function. There is also a complementary inference. Second, for any discriminable functional difference, there must be a discriminable difference between qualia. End quote. Having described this classical functionalist linkage between qualia and function, Gray then introduces the anomaly of word color synesthetes. Whenever these individuals hear or see a particular word, they also have a conscious experience of a particular color linked for them to this word. As Gray comments, there is no evidence that the experienced color plays any functional role in the synesthete's auditory or visual processing of words. Indeed, the experienced color may actively interfere with such processing. Thus, there is no relationship between the occurrence of the synesthete's color experiences and the linguistic function that triggers them. This conclusion is incompatible with the functionalist analysis of conscious experience. End quote. The phenomenon of word color and number color synesthesia, therefore, clearly violates the functionalist principle of same functions, same processes. Another challenge to this functionalist position comes from the phenomenon of blind sight. In this curious condition, people who have suffered damage to the specifically visual areas of the brain or the pathways leading to them, and who claim to have no conscious experience of seeing, are yet able, when encouraged to do so, to perform almost as normal in terms of reporting what is in their apparently blind visual field. Lawrence Weisskranz is one of the leading researchers into blind sight and other sensory dissociations, such as deaf hearing, and amnesiacs who can, when pressed, remember almost everything one would expect them to. Given the existence of all these phenomena, Weisskranz raises the possibility of a condition which could be called a true zombie. Weisskranz explains that it should be theoretically possible for one individual to have damage to all their sensory modules, or perhaps to a single awareness module. As he comments, one would be left with just a bundle of implicit processes, a true zombie, if you will, end quote. Weisskranz emphasizes that he's never found such a case, having studied tens of thousands of neurological case reports. However, for our purposes, even the possibility of the true zombie, again and from an opposite direction, violates the functionalist claim of an inviolable link between functions and qualia. Popper's three worlds. Given, as we've seen, that the newer functionalism retained many of the failings of behaviorism, the great modern philosopher Karl Popper suggested reviving interactionism as a solution to the mind-body problem. Popper's version of interactionism differed in several important ways from Descartes. Firstly, rather than Descartes' two worlds, Popper proposes three. In addition to the Cartesian dichotomy between the physical and mental worlds, Popper introduced a third domain comprising the cultural products of the human mind. Additionally, in place of Descartes' dogmatic certainty, Popper proposes his system as a heuristic aid to understanding, which he insists is one of the main objectives of science. Though he modestly adds that complete understanding, just like complete knowledge, is unlikely ever to be achieved. Popper's World 1 comprises the material universe as revealed to us by modern physics. Popper points out that whether or not biology is reducible to physics, it appears that physical and chemical laws are binding for living things. Living things are, therefore, material bodies. They are processes, and like some other material bodies, clouds, for example, they are open systems of molecules, systems that exchange some of their constituent parts with their environment. They belong to the universe of physical entities or states of physical things. End quote. He also draws our attention to entities which are generally accepted as part of the physical world, but which conceptually are not material, such as processes, forces, fields of forces. Popper comments that they interact among one another and therefore with material bodies. Thus, we conjecture them to be real, even though their reality remains conjectural. Popper's World 2 consists of mental states. He claims that these states are real since they interact with our bodies. In support of this, Popper argues that the epiphenomenalist view is unsatisfactory. It admits the existence of a world 2, but denies it any biological function. It therefore cannot explain, in Darwinian terms, the evolution of world 2, and it is forced to deny what is plainly a most important fact: the tremendous impact of this evolution upon World 1. End quote. In this context, Popper emphasizes the active hypothesis testing nature of sensation and perception. Quote, "The neurophysiology of the eye and that of the brain suggests that the process involved in physical vision is not a passive one, but consists in an active interpretation of coded inputs. It is in many ways like problem solving by way of hypotheses. Our sense organs themselves may be likened to hypotheses or theories about the structure of our environment and about the kind of information most needed and most useful to us." End quote. Popper therefore regards the view that our perceptions are given to us as a mistake. They are made by us. They are the result of active work. End quote. Consequently, Popper claims that our visual perception is more like a process of painting a picture selectively than one of taking random photographs. End quote. Reality of World 3. As above, in addition to the more traditional concepts of a physical and mental world, Popper also posits the existence of a third world, that of the collective products of human minds. Popper makes three emphatic claims about the objects in this world. 1. World 3 objects are abstract, even more abstract than physical forces, but nonetheless real, for they are powerful tools for changing World 1. Secondly, World 3 objects have an effect on World 1 only through human intervention, more especially through being grasped, which is a World 2 process, a mental process, or more precisely, a process in which World 2 and World 3 interact. Thirdly, we therefore have to admit that both World 3 objects and the processes of World 2 are real, even though we may not like this admission out of deference, say, to the great tradition of materialism. End quote. Popper summarizes his position on World 3 by concluding, "Cultural evolution, we may say, continues genetic evolution by other means, by means of World 3 objects." As to actual examples of World 3 objects, Popper lists stories, explanatory myths, tools, scientific theories, whether true or false, scientific problems, social institutions, and works of art, and adds that World 3 objects are of our own making, although they are not always the result of planned production by individual men. End quote. Popper points out that many World 3 objects exist in the form of material bodies and belong in a sense to both World 1 and World 3. Examples are sculptures, paintings, and books. A book is a physical object and it therefore belongs to World 1. But what makes it a significant product of the human mind is its content, that which remains invariant in the various copies and editions. And this content belongs to world 3. Popper insists that world 3 objects are real in the sense in which human beings generally define this, which he describes as follows. The entities which we conjecture to be real should be able to exert a causal effect upon the prima facie real things, that is, upon material things of an ordinary size, that we can explain changes in the ordinary material world of things by the causal effects of entities conjectured to be real." End quote. Popper's revival of interactionism led his collaborator and co-author, the Nobel Prize-winning neurophysiologist John Eccles, to focus on a very concrete and literal interpretation of the interactive process. Eccles argued that this interaction is located in specific areas of the brain, and he formulated the mind-body problem as the problem of describing, in as much detail as possible, this liaison between the brain and the mind. Function versus tissue. These speculations from the neurophysiologist Eccles brings us back to the issue of confronting functionalism, this time from a biological point of view. Gray labels this the function versus tissue question. Dennett, in this sense a classical functionalist, dismisses all attempts to insist that mental states can only be generated by biological structures and processes, with a contemptuous reference to wonder tissue. Gray reiterates the standard functionalist position that it's the circuitry in the brain that produces the mind, regardless of what it's made of. He adds that a robot equipped with all human functions would be conscious, irrespective of the materials from which it was constructed. In opposition to this, a number of theorists have insisted that real consciousness is ultimately a biological phenomenon. Among them, Searle claims that there can be no genuine consciousness in the sense of human meaning and understanding in the absence of the causal powers of neurons, a position he characterizes as biological naturalism. The biology and physics of neural tissue. I'll give two examples here of researchers who have concentrated on the special qualities of neural tissue in relation to the problem of consciousness. The first is the work of Crick and Koch on 40 Hz oscillations. As Andy Clark explains, the focus of the work is on the neural mechanisms that achieve binding, where binding involves establishing a certain relation between neural populations carrying different types and items of information, e.g., binding MT motion detectors to V4 hue detectors as part of the process representing a certain face in the act of speaking. End quote. Such binding, Crick and Koch claim, is achieved by frequency-locked oscillations in the various neural populations, with the locking perhaps mediated by circuitry linking the cortex to the highly connected thalamus, the so-called thalamocortical loop. Spike synchronizations in the 40 Hz range, actually anywhere between 35 and 70 Hz, are then depicted as joining the various neural representations into a coherent whole, which is then placed in working memory, which in turn renders the coherent percept poised for the widespread control of action and report. Geoffrey Gray notes that this concept of the neural correlates of consciousness, specifically for vision, is incompatible with the notion of a single Cartesian theater for all conscious experience. Crick's approach implies, in contrast, that there will be multiple foci of neural activity, each proximal to a different type of qualia. However, it further implies, unlike Dennett's multiple drafts model, that only some forms of neural activity can serve as neural correlates of consciousness. In particular, neural correlates of consciousness should be found in perceptual systems, since one is consciously aware of percepts, but not in systems whose operation does not figure in conscious awareness. Ones, for example, that control pupillary dilation or walking. My second example of a neural tissue focus is the work of Penrose and Hamerhoff, who are concerned with the possible quantum processes taking place in neural tissue. Penrose and Hamerhoff are thoroughgoing in their panpsychism. As Stuart Hamerhoff says, we address the hard problem through a philosophical approach known as pan-experientialism, dating to Whitehead, who saw consciousness as occasions of experience in a wider basic field of proto-conscious experience. In our view, the wider field is fundamental space-time geometry, the fabric of the universe, which is everywhere at the Planck scale. Consciousness is a series of events, quantum state reductions in quantum space-time. And Gray explains that the quantum state reductions of this quote are the fundamental tool in the theory. As well as the hard problem of consciousness, Penrose and Hamerhoff address two major outstanding problems in fundamental physics: the manner in which the strange microscopic world of quantum mechanics collapses to give rise to the macroscopic world of everyday life, and the unification of quantum mechanics and quantum gravity. The theory is nothing if not ambitious. It proposes an interlinked solution to all three of these problems. Unit 7 of this course will be devoted entirely to quantum theories of consciousness. Velmans, what and where are experiences? Turning back to the metaphysical framework within which to best conceptualize consciousness, the psychologist Max Velmans has suggested a highly original approach. He points out that in dualism, light rays traveling from the physical object stimulate the subject's eye, activating the optic nerve and appropriate parts of the brain. This results in a conscious experience in the subject's mind. It's clear that there are two fundamental splits in this model. First, the contents of consciousness are clearly separated from the material world. And second, the perceiving subject is clearly separated from the perceived object. Consequently, dualists have traditionally been content to accept that there may be aspects of human experience that are beyond the reach of science. But for those who are committed to a naturalistic worldview, this is unacceptable. Reductionism, therefore, tries to resolve the conscious experience physical world split by eliminating conscious experience or reducing it to something that an external observer can, in principle, observe and measure. That is, it tries to collapse how things appear from the subject's first-person perspective to the brain state or functions that can be observed from a third-person perspective. But reductionism retains the split implicit in dualism between the observer and the observed. The perceived object remains quite separate from the conscious experience of the object. Velmans, the scientific observer. Thus, despite their profound philosophical differences, Velmans identifies a common position as to where the objects of experience are located. Quote, "For dualists, all experiences are rather like thoughts, which are not really anywhere, while for reductionists, experiences are really neural states or functions distributed around the brain. However, if forced to point, they would point vaguely at the brain." End quote. It's clear from this simple combined model why consciousness is often thought to elude scientific study. From a scientific observer's perspective, the physical cat and the subject's brain are potentially visible. They appear to be public, objective, and viewable from an external third-person perspective. Consequently, a scientific study of cats and brains presents no philosophical problems. By contrast, the subject's experience of a cat seems to be private, subjective, and viewable only from the subject's first-person perspective. If so, how can it form a datum for science? But, asks Velmans, what makes one human being a subject and another an experimenter? Their different roles are defined largely by differences in their interests in the experiment, reflected in differences in what they are required to do. End quote. The subject focuses only on his own experiences. The experimenter is interested mainly in these experiences which the subject is having, and in how these depend on the light stimulus or brain states he can observe. However, as Velmans points out, the subject and experimenter merely have to switch the focus of their attention in order to exchange roles. Following current conventions, the subject would then be entitled to think of his observations of the light and the experimenter's brain as public and objective, and to regard the experimenter's experience of the light as private and subjective. But as Velmans concludes, if the phenomenology of light remains the same, whether it is thought of as a stimulus or an experience, is the phenomenon private and subjective, or is it public and objective? End quote. Velmans' reflexive model. Velmans proposes what he calls the reflexive model to resolve these anomalies and confusions. According to this, while the subject is gazing at the cat, his only visual experience of the cat is the cat he sees out in the world. If he is asked to point to this phenomenal cat, his cat experience, he should point not to his brain, but to the cat as perceived out in space beyond the body's surface. End quote. There isn't a phenomenal cat in the mind in addition to the cat one sees out in the world. Applying Occam's razor, the reflexive model gets rid of them. End quote. Velmans concludes that each private observation or experience is necessarily subjective, in that it is always the observation or experience of a given observer, viewed and described from his or her individual perspective. However, once that experience is shared with another observer, it can become intersubjective. That is, through the sharing of a similar experience, subjective views and descriptions of that experience potentially converge, enabling intersubjective agreement about what has been experienced. End quote. On the other hand, Velmans wants to make it clear that nothing physical is projected by the brain. There are, for example, no light rays projected through the eyes to illuminate the world, contrary to the beliefs of ancient Greek thinkers. Rather, perceptual projection is a psychological effect produced by unconscious perceptual processing. End quote. Finally, Velmans makes the interesting suggestion that the object seen out there might be a kind of neural projection hologram. This can project a three-dimensional image out in space in front of its two-dimensional surface, quote, provided that it is viewed from an appropriate frontal perspective and it is illuminated by an appropriate frontal source of light. If it is viewed from any other perspective, from the side or from behind, the only information one can detect about the object is in the complex interference patterns encoded on the holographic plate. End quote. Velmans is suggesting by analogy that the neural projection hologram is displayed as a visual three-dimensional object out in space only when it is viewed from the appropriate first-person perspective of the perceiving subject. Quote, "The information displayed in the three-dimensional holographic image is encoded in two-dimensional patterns on a plate, but there is no sense in which the three-dimensional image is itself in the plate." End quote. Likewise, there is no sense in which an observed phenomenal cat is in the head or brain of the observer. In fact, the 3D holographic image does not even exist as an image without an appropriately placed observer and an appropriate source of light. Likewise, the existence of the phenomenal cat requires a conscious subject to perceive it. Humphrey, differences between sensation and perception. In terms of theorizing inputs to the brain and how it processes them, Nicholas Humphrey's contribution has been to insist that sensation and perception, as he defines them, represent radically separate and distinct channels from the environment to the brain. Humphreys claims that sensation is characterized by the following qualities. Sensations always belong to the subject. They are owned in a direct and personal way. Sensations are always tied to a specific body site. In other words, they're anchored in time and space and firmly located in the brain's map of the body. Sensations are modality specific, meaning that they are always experienced as a sight, sound, touch, taste, or smell. Sensations exist always and only in the present tense. And finally, taken altogether, these characteristics mean that sensation marks a boundary between me and not me. It tells us what's happening to me rather than what's happening in the environment. In an effort to link Humphrey's ideas about sensation to previous theories, we can certainly associate them. Firstly, with the notion of embodiment, as articulated by Maturana and Varela, Lakoff and Johnson, and others. And secondly, with the philosophical concept of qualia, which are often defined as raw fields. Significantly, qualia are also defined as private, personal, and impossible to communicate directly to others. In contrast, perception, according to Humphrey, produces abstract knowledge about what's happening out in the environment. It's not personal, time and space bound and tied to the body, as sensation is. And perception was a later evolutionary development than sensation. For a unicellular organism, sensation, which told it what's happening to me, was all the input that was necessary. But as complex multicellular organisms developed, they needed to know more and more about what was happening in their environment, including those parts of it which were quite distant from them. Perception evolved to meet this need. This division of the nervous system into a fast, immediate channel delivering personal raw feels and a slower analytic system delivering abstract knowledge at a distance fits in very well with much of the theorizing about the two different forms of computing, the classical digital and the connectionist parallel distributed processing alternative. Andy Clark, 1989, suggests, for example, that biological connectionism, which can be associated with Humphrey's concept of sensation, operates at a sub-symbolic level and is present in most mammals and possibly other varieties of animal. On the other hand, perhaps the higher apes, but certainly human beings, also have a slower classical system, which in humans has been enormously inflated by feeding on the cultural linguistic production of symbols in human communities. Humphrey, the privatization of sensory experience. Humphrey's theory of consciousness depends on a combination of his ideas about sensation with a phenomenon he calls the privatization of sensory experience. This can be described via a brief evolutionary tale. This starts with the capacity of unicellular organisms to respond to stimuli such as temperature, pressure, and chemical changes, which act directly on their membrane boundary. They also have the ability to evaluate these stimuli as toxic or beneficial. Unicellular organisms will then react with what Humphrey calls a wriggle of acceptance or rejection. This basic formula for sensation continued into the more primitive forms of multicellular organisms. But given the size of these creatures, this required a two-way traffic, with the stimulus traveling from the site of bodily stimulation all the way into the animal's nervous center, and then the wriggle reaction traveling all the way back again to the site of stimulation. In higher mammals, and especially humans, Humphrey suggests that this return journey of sensation may be short-circuited. Rather than returning to the site of stimulation, the wriggle of acceptance or rejection is instead diverted to the detailed map of the body located in the human brain. This short-circuiting results in the wriggle of response becoming a virtual wriggle, which will reverberate around and around these neural networks in the brain. Humphreys claims that this reverberation is the neurological basis of consciousness. Humphrey also has a very original theory as to the function of consciousness. Most people assume, he says, that the role of phenomenal consciousness must be to provide the subject with some kind of new mental skill, end quote. In other words, being conscious must help us to improve the performance of certain important tasks. Humphrey, however, rejects this conventional view, claiming that the role of consciousness, quote, is not to enable you to do something you couldn't do otherwise, but rather to encourage you to do something you would not do otherwise, to make you take an interest in things that otherwise would not interest you, to mind about things you would not otherwise mind about, or to set yourself goals you otherwise would not set. End quote. In other words, being conscious motivates us to want to go on living, which in a highly complex, sensitive, and intelligent creature may be a very necessary function. In fact, Humphrey suggests that the magical nature of conscious experience leads us to believe that we have immortal souls, which in turn provides us with an evolutionary advantage. Hofstadter's strange loops. Humphrey doesn't say much about the nature of this reverberating loop of sensation which he claims generates consciousness. When he does, however, he refers to Douglas Hofstadter's theory of the strange loop. Hofstadter defines a strange loop as, quote, not a physical circuit, but an abstract loop, in which, in the series of stages that constitute the cycling around, there is a shift from one level of abstraction or structure to another. A strange loop feels like an upwards movement in a hierarchy, and yet somehow the successive upward shifts turn out to give rise to a closed cycle. That is, despite one's sense of departing ever further from one's origin, one winds up, to one's shock, exactly where one had started out. In short, a strange loop is a paradoxical level-crossing feedback loop. Hofstadter emphasizes the abstract, mathematical rather than physical nature of strange loops, and consequently ourselves. Quote, the thesis of this book, he says, is that we ourselves, not our bodies but ourselves, are strange loops. End quote. As above, Hofstadter also emphasizes the conversion or elevation of raw fields to symbols as crucial to the generation of self and consciousness. He says, in any strange loop that gives rise to human selfhood, the level of perception, abstraction, and categorization are central, indispensable elements. It is the upward leap from raw stimuli to symbols that imbues the loop with strangeness. The overall gestalt shape of oneself, the stable whirl, so to speak, of the strange loop constitutes one's I, is not picked up by a disinterested neutral camera, but is perceived in a highly subjective manner through the active processes of categorizing, mental replaying, reflecting, comparing, counterfactualizing, and judging. End quote. Hofstadter tries to convey the peculiar mathematical nature of strange loops by describing how, in twisting back on itself, it violates the rules of hierarchy, which are deeply embedded in our minds. He states this as follows. A loop's strangeness comes purely from the way in which a system can seem to engulf itself through an unexpected twisting around, rudely violating what we had taken to be an inviolable hierarchical order. End quote. The origin of a lot of the ideas behind the concept of the strange loop, Hofstadter attributes to Gödel's theorem. Here is part of his attempt to explain this, quote, "If Gödel had concocted a self-affirming formula that cockily asserted of itself, this formula is not provable via the rules of Russell and Whitehead's Principia Mathematica, the strange loopiness resides not in the flip due to the word not, but in the unexpected, hierarchy-violating twisting back involving the word this." End quote. Hofstadter again insists that when I refer to a strange loop inside the brain, do I have in mind a physical structure, some kind of palpable closed curve, perhaps a circuit made of many neurons strung end to end? Could this neural loop be neatly excised in a brain operation and laid out on a table like a delicate pearl necklace for all to see? And would the person whose brain had thus been de-looped thereby become an unconscious zombie? And he concludes that, needless to say, that's hardly what I have in mind. The strange loop making up an I is no more a pinpointable, extractable physical object than an audio feedback loop is a tangible object possessing a mass and a diameter. Such a loop may exist inside an auditorium, but the fact that it is physically localized doesn't mean that one can pick it up and heft it, let alone measure such things as its temperature and thickness. An I loop, like an audio feedback loop, is an abstraction, but an abstraction that seems immensely real, almost physically palpable to beings like us." End quote. Rediscovering the emotional brain. Continuing with our survey of the shortcomings of cognitivism and critiques to address these, the next big issue is cognitivism's long-term neglect of emotion. Science had not always ignored the topic of emotion, as Antonio Damasio explains. By the end of the 19th century, Charles Darwin had made incisive observations on the expression of emotions in animals and humans, and had placed emotion in the perspective of biological evolution. William James had produced a scientific description of the phenomenon of emotion, thus opening the way to its experimental study. And Sigmund Freud was writing about the means by which emotion might play a role in psychopathology. Somebody freshly arrived on Earth in 1994 and interested in the topic of emotion would have good cause to wonder why such groundbreaking developments did not lead to an assault on the neurobiology of emotion. What could possibly have gone wrong in the intervening century? The simplest answer is that emotion has received benign neglect from neuroscience and has been passed over in favor of the study of attention, perception, memory, and language. End quote. Jaak Panksepp is one of several eminent neurophysiological researchers who are currently asserting that the emotions are a product of evolutionary selection and that they are fixed and universal across the human species. Quote, I have argued that the capacity to have affective feelings is an evolutionary birthright embedded within the intrinsic and ancient organizational dynamics of the mammalian brain, situated largely in subcortical realms known as the extended limbic system. End quote. This is in sharp contrast to the standard social science model, which claims that emotional behavior differs significantly between cultures and that individuals learn to experience the emotional expressions appropriate to their culture, rather than inheriting a universal range of emotions at birth. Panksepp takes this further by arguing that emotions evolved to provide fast-acting signals for guiding behavior in accordance with the requirements of survival and reproduction, or what Panksepp calls biological values. Quote, my view affirms that the evolution of emotional feelings was linked to the special needs of brain memory systems that must rapidly encode intrinsic biological values. End quote. Another researcher in this field, Edmund Rolls, expresses this role of emotion by claiming that their evolution enabled genes to specify goals and rewards rather than behavioral responses themselves. Quote, the theory that genes set many goals for action does not mean that our behavior is determined by genes. Modern evolutionary theory has led to the understanding that many traits, particularly behavioral ones, may have some genetic basis, but that does not mean they will inevitably appear, because much depends on the environment. The power of the theory of emotion described here is that in evolution, genes specify rewards and punishers that are goals for action, but do not specify the actions themselves, which are flexible and can be learned. End quote. The evolutionary function of emotion. Rawls goes on to identify this as the evolutionary function of emotions, i.e., enabling flexibility of behavioral response. Quote, emotions have the important evolutionary role of enabling genes to specify the goals, i.e., the rewards, etc., that produce emotions, for actions rather than the actions themselves. The advantage of this Darwinian design is that although the genes specify the goals, the actual actions are not pre-specified by the genes, so that there is great flexibility of the actions themselves. This shows how genes can influence behavior without specifying a fixed instinctive behavioral response. End quote. The brain processes which generate rewards and punishments in conjunction with particular experiences or representations are crucial to achieving this flexibility. The action systems in the brain are designed to optimize the output of the reward and punishment systems. Put another way, the brain systems involved in motivation and emotion must pass on reward or punisher signals to the action systems, which then attempt to obtain and maximize the reward signals being received. Since it's the range of emotional responses and not the behavioral responses that are fixed, the brain can switch behavior from one reward to another as the reward signals being received change. It can also, of course, switch behavior if signals indicating possible punishers are received. It's interesting to note that Rawls's decoupling of a necessary direct link between genes and behavior opens the way for cultural evolution and all the socio-cultural phenomena covered by Richard Dawkins' neologism, memes. In other words, human beings use their emotional reactions as calibrated by early experience to judge which of the possibly many patterns of social and cultural behavior to which they are exposed they wish to imitate. Emotion and behavioral flexibility. The thrust of the argument from these new emotion theorists is that emotion may be the basis for our immediate primal sensate consciousness. This is in sharp contrast with, for example, the perspective in the field of artificial intelligence, which links intelligence, if not consciousness, with mathematical digital processing rather than the rapid analog forms of emotional reactions. As Andy Clark suggests, the truth is probably that we have both types of mental processing, but as the new theorists insist, the emotion-based system is biologically predominant. Empirical research has established that the human species has 6 universal primary emotions: happiness, sadness, fear, anger, surprise, and disgust. All human cultures recognize these mental states, and individuals within them can correctly interpret the facial expressions appropriate to each, regardless of the culture or ethnicity of the face they're looking at. A good metaphor for the emotions, according to these new theories, may be to compare them with the semaphore signaling system. Like the human emotions, semaphore has a fixed set of signs or configurations, but it is capable of expressing an almost infinite number of situations. To extend the metaphor, each human organism learns to associate one of the 6 emotions, or some combination of them, with particular experiences and situations. This may in fact be the most primeval level of meaning in the brain. These emotional responses then signal the brain's motor system to produce an appropriate behavioral response. The flexibility comes from the notion that the associations between the 6 emotions and particular experiences is not fixed. It can change via learning and/or dramatic changes in the life experience of the individual. It may be, as per Humphrey's theory earlier, that the drama and magic of consciously experienced emotions, plus other qualia, is what provides humans with their internal motivations, especially the motivation to go on living. The behavioral flexibility provided by the human range of emotions also contributes to our ability to plan. This capacity may have been decisive, for example, in Homo sapiens winning out in competition with Neanderthals when they first encountered each other in Europe about 30,000 years ago. The Neanderthals were opportunistic hunters, while the behavioral flexibility of Homo sapiens enabled them to plan their hunts using their knowledge of the terrain and the movements and behavior patterns of their prey. Damasio's somatic marker hypothesis. Antonio Damasio has developed the theory of somatic markers, which he claims help us to make decisions. Quote, "Somatic markers are associations between reinforcing stimuli that induce an associated physiological affective state." End quote. In other words, we evaluate experiences according to the reactions they elicit from our built-in emotional equipment. When a similar experience occurs, this triggers the memory of the original experience. This is what Damasio calls the automated signal. Quote, "When we make decisions, we must assess the incentive value of the choices available to us using cognitive and emotional processes. When we face complex and conflicting choices, we may be unable to decide using only cognitive processes, which may become overloaded and unable to help us decide." End quote. Damasio uses the metaphor of the body as a theater for emotional reactions. Life is like a drama where the appearance of certain characters and situations is marked by our physiological reactions. When they reappear later in the drama, we recognize what they mean to us by the emotions they provoked the first time, which are now repeated as a marker. This automated signal system protects us by providing an early warning system and enables us to choose from among fewer alternatives. In other words, it's our first line of decision-making. Damasio says, there is still room for using a cost-benefit analysis and proper deductive competence, but only after the automated step drastically reduces the number of options. Somatic markers may not be sufficient for normal human decision-making, since a subsequent process of reasoning and final selection will still take place in many, though not all, instances. Somatic markers probably increase the accuracy and efficiency of the decision process. Their absence reduces them. End quote. Damasio has used psychological experiments based on gambling to test his somatic marker theory. In essence, these experiments use two types of card decks. One fair deck, the other one deliberately rigged to ensure big losses for the gambler. The question was, given a choice between the two decks, how long would it take subjects to learn to choose the fair decks over the rigged ones? Most healthy participants sample cards from each deck, and after about 40 or 50 selections are fairly good at sticking to the good decks. However, people with a particular neurological problem known as orbitofrontal cortex dysfunction, however, continue to choose the bad decks, sometimes even though they know that they are losing money overall. Measurement of the galvanic skin response shows that healthy participants show a stress reaction to hovering over the bad decks after only 10 trials, long before they become fully conscious that the decks are bad. By contrast, subjects with this neurological dysfunction never develop this physiological reaction to impending punishment. Alan Shaw has argued that the left orbitofrontal cortex essentially is the Freudian unconscious. In other words, it plays a crucial role in our emotional lives, especially with regard to the social emotions. And in fact, all the new theories of emotion emphasize the importance of the social aspect of emotion. Edmund Rolls, for example, says, when considering the adaptive value of emotion in the context of evolution, we must remember that animals are generally social and that evolution may have led to the development of special reward and punishment systems to help to produce emotional behavior that is adaptive in social situations, end quote. Given that Homo sapiens developed the largest groups of any primate, they had and have the most complex social lives, and consequently they needed the most highly developed and wide-ranging set of emotions. Ironically, humans may have the largest brains of any animal, not because they are the most rational of the animals, but because they are the most emotional.